We have been discussing about this microsystem for micro robotic related applications, like we have been discussing about the different micro actuation strategies which have been deployed and different technologies which have been evolved with reference to microsystem perspective point of view. In fact, we have seen some of the case studies where we have used a kind of a micromotor for the movement of biomedical related applications. We have also checked some case studies where we have used people have used micromagnetic systems for different applications. In fact, we had discussed about the different configurations of micro pumps and the applications of micro pumps in detail. In today's lecture, we will discuss about one of the key aspect which is called as piezoelectric based micro engines. So, as far as these piezoelectric based micro engines are concerned, so piezoelectric micro engines harness the mechanical deformation of piezoelectric material under applied electric field. These engines can produce a precise high frequency motion with relatively low voltage requirements and low voltage requirements. Some of the common design which basically includes the ultrasonic motor and the inchworm motor. So, as far as these ultrasonic motors are concerned, it is used for traveling or standing waves in piezoelectric related elements. However, in the case of inchworm is concerned, it employs a sequential clamping and extension of piezoelectric actuator. For instance, if you remember, so we had discussed about this inchworm mechanism, where there will be a kind of a opening and closing of an actuation alternatively. By opening and closing these actuations, so appropriately we can get a kind of a displacement which is in the order of few microns. Now, this will be helpful for us, like appropriately sequencing this opening and closing. So, we have a capability in changing the directions appropriately, as well as it also help us to change the frequency as well as the voltage as per our requirements or as per our characteristics. Okay. So, like we had discussed about this thick slip phenomenon. So, this thick slip phenomenon is one such examples where inchworms have been used for different applications. Now, in today's lecture, so we will discuss about more on this ultrasonic motor. So, as far as this piezoelectric captured ultrasonic motor is concerned, like it uses an ultrasonic frequency with piezoelectric vibration generated waves, and these waves are used to get transformed in the electrical energy into a rotary or in the form of a translating motion. So, the USM receives more attentions because they offer distinct qualities over the traditional magnetic coil based motors such as miniaturization. It also has a greater accuracy. Most important, it has quite a good amount of speed. It is non-magnetic in nature. It has a silent operation, and it has a kind of a straightforward construction, both with the temperature operations and adaptability. So, let us see some of the key characteristics of this piezoelectric based motor. So, let me just take you around the basic operation of this piezoelectric based ultrasonic motor. So, as far as in this piezoelectric based ultrasonic engines are concerned, so there is going to be a stator, a rotor, stator, a runner cum rotor which has a moving direction, and there are some connections over here which has been integrated into the system. So, ideally this is the stator and this is going to be the driving foot, and it has a rotation something like this. Let us represent it as A, B and C. Now, if we closely observe these operation principles, so this ultrasonic piezoelectric motor comprises of two primary components, a stator and a rotor. A stator, as we all know, it is an immobile part that contains a kind of a piezoelectric component, and the stator or travelling wave motor, while rotor is a mobile part that works with the stator to produce a rotation or a kind of a linear movement. Now, this ultrasonic piezoelectric based ultrasonic system, it's a kind of a concept which converts the spiraling drive foot motion to the movement of the rotor through the friction interaction that occurs between the rotor and its stator. So, it is something like this: the pushing element of the circular motion moves the runner with a friction force, while the pressing element shifts the force that is normal within the driving foot and the runner on a periodic basis. So, the pushing and pressing element are parallel and perpendicular to the runners, which is a kind of a travelling trajectory respectively. Now, as far as in this particular case is concerned, like if you see the overall classification, or if I try to look into the overall advantage of this particular system. So, when I try to categorize with reference to different parameter perspective point of view, when I consider a voltage, it requires a very less voltage with reference to size and weight. It is highly compact and lightweight. It can work in both air and vacuum environment, and it has a kind of a silent operations. Most important, with reference to electromagnetic perspective point of view, it does not has any kind of electromagnetic interference, and it has a kind of a high torque at low speeds. And a very important aspect with reference to these piezoelectric and ultrasonic based systems are they have a very fast response time as compared to any other systems, and basically these are some kind of simple design. It has a stable performance across a wide range, and it has a high efficiency, especially at the low speeds. So, these are some of the advantages of such kind of systems. However, with reference to disadvantage perspective point of view, they usually generate a small power with low efficiency that involves a two-step energy conversion techniques. And like in this particular case, there is a transformation of stator vibration into a macro one directional motion of the rotor via the friction between its rotor and the stator, which may cause a kind of a energy losses. Now, let us see some of the classification of this particular system. So, if we closely observe the classification based on the functionality, these systems are classified like so, if we try to look into the overall classification of this system, the ultrasonic piezoelectric motors are classified based on the degrees of freedom like either it might be a kind of a 1 DOF or it might be a multiple DOF. So, in the case of a 1 DOF, it is classified as rotary motion and this is classified as a linear motion. In the case of multi-degree degrees of freedom perspective point of view, it is classified as spherical motion a planar motion and a cylindrical motion. Now, in addition to this, this is also classified based on the wave propagation. That is, it can be a kind of a travelling wave or standing wave or a hybrid wave. So, in the case of a travelling wave is concerned, it is a kind of a radial mode of cylinder based on the geometric shape. It can be considered as a radial mode of cylinder. Then we have the axial bending mode of disc and the axial bending mode of ring shape. Similarly, in the case of standing waves is concerned, it is based on the rotary direction. We can classify as unidirectional motion and a bidirectional motion. And with reference to hybrid wave perspective point of view, it can be classified as longitudinal based, longitudinal bending, longitudinal torsion, okay. So, these are some of the classifications with reference to these piezoelectric ultrasonic based micro engines. Now, let us discuss about the concept of the thermal micro engines. As far as these thermal micro engines are concerned, these thermal micro engines are mainly meant for converting a one form of thermal energy into a mechanical work. So, often it is used for leveraging the high surface area to volume ratios at micro scales for efficient heat transfer. So, some of the examples of these thermal micro engines basically includes a bimetallic actuator. So, the main function of this bimetallic actuator is it tries to encache the different thermal expansion which happens within it. Like we all are aware about a bimetallic actuator. So, ideally a bimetallic actuator looks something like this. So, it has two different combination of two different material. Basically, we are trying to encash the specific heat capacity of the material, the thermal conductivity of the material appropriately. We can initiate a kind of an actuation what we are looking for. As far as shape memory alloy perspective point of view, so we are trying to utilize the phase transformation. In fact, we had discussed a lot about shape memory alloy based transformation. It is something like switching between an austenite phase and a martensite phase. So, we are trying to utilize the phase transformation in the material like NPTEL-NOC. And then we can also have this thermo-pneumatic engine, which basically it uses a kind of a gas expansion in the sealed chamber. So, we have a chamber in place. Inside this chamber, so there will be a kind of a thermal. These thermal material, when it gets heated up, so it will result in a kind of an expansion. This expansion will lead to a kind of an actuation in the system, and further we can have a control over the actuation with reference to an by giving an appropriate thermal sequencing to the system, and with reference to this thermal sequencing we can have a control over the motion. So, as far as in these particular cases are concerned, so these engines can generate a significant force, but basically it typically operates at low frequency due to the thermal cycling limitation. For instance, we have discussed about the shape memory alloys where it has its own limitations with reference to frequency perspective point of view. The maximum frequency which is reported is close to around 15 hertz, which itself requires a kind of a bonding. It can be exhibited only in the case of a bimorph based related applications. Now, as far as these shape memory alloy related heat engine is concerned, there is a concept which is available, which is called as a Johnson's heat engine. So, as far as this Johnson heat engine is concerned, there are two concentric circles, or like it is a kind of a wheel. The spokes of the wheel is made out of a shape memory alloy. So, to give a better understanding, the spring looks something like this. So, what happens is this spring is is in the form of it is in a deformed state, and this wheel is connected to an axis, and let us consider we are half immersing it in the hot water condition. So, when these wheels are immersed in the hot water condition, basically it is half immersed in the hot water condition. So, what happens is there will be a kind of a contraction and expansion in the spring. So, this spring will try to expand and then this spring will try to contract. So, the expansion, it is already the spring is in the tension, and when we try to put it in a hot water condition, it will try to get actuate, it is try to get contract. When this particular gets contracted, let us consider we have 3 sets of spring, and when these 3 sets of springs, when they try to contract, automatically there is going to be a kind of a shift in the center of gravity of this particular wheel. When there is a shift in the center of gravity, so there is going to be a rotation which will get enabled out of it. Now, if we closely observe in this particular construction, the input is in terms of heat, input is in terms of temperature gradient, and the output is in terms of rotation. So, when there is a kind of a temperature gradient is there which exists, this will result in a kind of a continuous rotation in the wheel, and this continuous rotations can be used for appropriate application. So, like either I can connect a kind of a cooling fan kind of arrangement, or I can fix up a dynamometer over here, or sometimes I can encash this displacement for appropriate application. So, I can just connect a small shaft along with this system, so that when I try to connect a small shaft along with this system, the wheel will rotate. This translated rotation, the rotation which is being generated by the shape memory alloy based wheel heat engine, can be appropriately translated in the form of a kind of a displacement, which is one way of having a kind of a rotation. Okay. And second important aspect is, since it is like the input for this system is due to the variation in the temperature gradient. So, by adjusting the temperature gradient appropriately, we can expect a rotation. So, now we have a flexibility. So, as we have seen, the shape memory alloys, basically the commercially available shape memory alloys is in the order of is a nickel titanium based material, and these nickel titanium based materials can be efficiently actuated within the range of something around 40 to 60 degrees Celsius, which is sufficient enough so that when we try to supply a localized heat in a particular concentrated region. So, what happens is the spring will get actuated as and when the spring gets actuated. So, appropriately we can see a kind of a rotation which exhibits over here. Okay. Now, here in this particular case, what we are observing is a kind of a rotation, it is a kind of a rotation because the geometry is in the form of a wheel. However, alternatively we can also deploy such kind of arrangements where we have a two legged system which is made out of SMA bimorph. Okay. So, these SMA bimorph, as we have seen, so it has a kind of a thin film integrated with the polyamide structure, so that when the actuation happens, this polyamide structure gets actuated and appropriately we can get a displacement. So, this is going to be a kind of an SMA bimorph. Let us consider we can prepare a small inchworm based SMA bimorph, and then we can appropriately supply a kind of a relay circuit to the system, and these relay circuits will provide a kind of a Joule heating to this particular SMA bimorph. So, what happens is when we try to give a small pulsative heating to this particular SMA bimorph, this SMA bimorph will try to displace in a particular orientation. This displacement will result in an actuation of such kind of structures, where we can see a kind of an appropriate displacement which exhibits over here. So, the same technique can be deployed for a bimetallic based inchworm. So, if we closely observe the SMA bimorph and the bimetallic based inchworm, both will almost have the will have the same thermal cycle. However, in the case of shape memory alloy, we have a capability to tune the thermal cycle by appropriately applying a strain percentage to the system. Okay. So, now once we come back to this SMA based heat engine is concerned. So, the actuation of this SMA based heat engine is highly controlled by the amount of temperature gradient which exists. Now, we have a provision in place that this temperature gradient can be generated either through a liquid or it can also be generated through an air. So, like appropriately generating a kind of a actuation through an air, hot air, so that we can create a kind of a rotary system. For example, let us consider an arrangement something like this. This is a kind of an SMA spring. This SMA spring is connected to a roller. Now, we have a focused air which is made to hit this particular surface. So, this when the hot air with a temperature in the range of 40 to 50 degrees Celsius, when it is striking this shape memory alloy spring, what happens is this shape memory alloy spring will contract, which will result in the shift in the center of gravity, which will allow the wheel to move in a particular direction. Similarly, when I try to cut off the hair, this shape memory alloy will expand, and finally it will result in the stoppage of this rotation. So, here in this particular case, so whenever we are considering a kind of a small mobile robot, where there is going to be a thermal heat, when we consider thermal gradient as our input. So, appropriately by supplying a thermal gradient, so we can generate a kind of a rotation, even we can use it for certain amount of mobile platforms, etc. Another aspect with reference to this shape memory alloy based heat engines are like suppose we have a kind of a circuit and these circuits are generating quite a good amount of heat. So, now we can have a kind of SMA based cooling fan system. So, that this SMA based cooling fan systems are connected with a fin kind of arrangement, and when a heat is getting generated, this fan starts rotating and appropriately it will try to quench the heat which is being generated over here. So, these are some of the applications where SMA based heat engines can be deployed. Okay. Now, let us take one more case study where it is a kind of a micro heat engines which are being deployed. So, as far as these if you try to look into the construction of this micro heat engine, there is going to be a polymer gasket which is available, then there is going to be an expander membrane, a saturated mixture and a liquid reservoir. Now, there is going to be two important structure, one is a kind of a wicking structure, another one is a kind of an evaporator membrane which is available. So, in this particular case, an individual micro engine consists of a cavity filled with a saturated two-phase working fluid bounded on the top and bottom by thin membranes. So, the bottom membrane acts as an evaporator. A capillary wick fabricated on the top of the membrane controls the layer of the liquid phase working fluid on the evaporator. So, the top membrane of the cavity is the expander and fluxing, and it will result in a kind of a mechanical work. So, ideally, so in this particular case, so we get a kind of a resonator displacement coming out of this using this particular system. So, in this particular system, if we keenly observe, there is going to be an expander membrane and then there is going to be a evaporator membrane and a liquid reservoir. So, like this will result in a kind of a peristaltic motion. So, this peristaltic motion will be helpful for us to create a kind of an inchworm mechanism what it is expected. Okay. So, these are some of the examples where like thermal based systems can be deployed for generating certain amount of micro actuations. These are kind of integrated systems which can be integrated with the systems for developing a particular applications.